Hello, Padres, to our next Edpuzzle. This one is going to prepare us for our Wednesday lab. It also could be a Thursday lab, depending on which period you have me. So we're going to kind of go through what we're going to be doing. We're going to have two parts. The first part, we're going to use a toy car. It's going to look like this, and it has a button on the side which turns it on, and the car is going to drive at a constant speed. So that's going to be for part one. So the first thing we're going to do is we're going to decide on what split times you're going to do. So you can time this car every second. Maybe you want to time it every 2 seconds, maybe every 3 seconds. But you're going to set it down. You're going to say go. And then if your group decides 2 seconds, it'll be 1, 1,000, 2, 1,000. You're going to mark this spot with a piece of tape. 3, 1,000, 4, 1,000. You're going to mark this spot. 5, 1,000, 6, 1,000. You're going to mark this spot. And you're going to mark those spots for a total of 4 times. And then you're going to measure the distance. You're going to measure the distance from the start to the first mark, the start to the second piece of tape, the start to the third, the start to the fourth, and you're going to get a nice little chart, some data. Then you're going to use our equations to find the velocity, how fast the car was going. You are going to graph the data so you can actually see it on a graph, and you're going to do this 3 times. Then there are some analysis questions. So let's take a look at this. I have a sample at the bottom. So you're going to erase the red typing, and you're going to put your information there. So erase the red, put in your names. Part 1 says car name. What car do you have? So this car is 5X. It's written on the back. Write down your procedure. So think about the peanut butter and jelly sandwich. Be specific. How often are you measuring it? What are you doing? And then do it. And you're going to collect your data. So for me, for this one, I did every second. So you can see I did it in 1 second, 2 second, 3 second, 4 seconds. I'm going to center my data so it looks a little nicer. And then I collected the distance. It was 2 meters for the first second, 4 meters for the second second. And then you're going to get a graph. So let me show you how to do this. You're going to create a Scratch Google Sheet. So open up Google Sheets, create a Scratch one. You're going to put in your columns. So here is my times. I'm doing 1 second per piece of tape. And these are the distances that I got for my 4 seconds. This is trial 1. This is trial 2. And this is trial 3. So I can copy this. If I select it, I can copy it. I can take it over to my lab, and you can paste it. You can link it, and if you link it, what will happen is if you make any changes on your Scratch piece, what happens is over here, it should change. Looks like it's lagging a little bit, but it should change. That should be a 2. Refresh the page. Well, it's not changing. It should change if it's linked. Okay. The next thing we need is there it is, the update. So I hit update. That should update it and change it. So the next thing we need is a graph. So to get a graph, we need to graph our data. So we're going to go back to our Scratch sheet. We're going to select the data. You're going to insert a chart. And it's going to bring up this. We don't want a bar chart, though, bar graph. We want, we're going to scroll around chart type. We want scatter plot. So we're going to scroll down until we hit scatter. And now we get our nice looking dots here. We have one for the yellow, one for the red, one for the blue. And then we're going to go to Customize. And if you go to Series and you scroll down, here's a trend line button. And if we click the trend line button, it does a best fit for our data points. So you can see this data point is a little bit off. It's a little bit below the line. So it's a best fit line. And then finally, you can change the type of fit. So if you think it's an exponential fit, exponential, polynomial. So you can see like some of these aren't fitting very well. Like that definitely does not fit the line. So it looks like our data is linear for this one. It looks like the line linear hits most of those points. And then finally, we can come down and we can label these. And we're going to label these with use the equation. And it gives us an equation. The equation is the slope-intercept form. So it's y equals mx plus b, where m is the slope of the line and b is the y-intercept. So it does all that math for us, and it gives us the slope. And then you can do the same thing. You can copy this, go over to your nice, neat lab, and then you can get rid of mine, and you can paste yours in, link it if you want. Like I said, the linking is kind of nice because then if you come back later to your Scratch sheet and you're like, oh, this piece of data was bad, you can change it to 20. And then when you come back to your lab, you can update, and it'll update the data. So you can see like this yellow point shot way up here. So that's kind of neat. So now we got our chart. Calculations, you're going to calculate the velocity for each trial. So show your work. You're using the last distance and time. So I have 8 meters and 4 seconds. You can see that's right here, 8 meters, 4 seconds. Distance divided by time, or displacement divided by time. You're going to have a summary table. So you'll have all 3 of your velocities. And then for the fourth one, you're going to calculate the average. So you'll have an average velocity for your car. And there's some summary questions. Part 2, let's scroll back up to the top. Part 2, we're going to place a car on a slope. For this one, we're not going to use these cars because these cars go the same speed all the time. So going down a slope is not going to make a difference. So instead, we're going to go out kind of by the cafeteria. There's a slope out there, and we're going to use these cars. These cars have just regular wheels that will roll. You're going to release the car. You're going to do the same thing. Every second or every 2 seconds, every 3 seconds, you're going to put a piece of tape down, and then you're going to measure the distances, and you're basically going to do the same thing. So for part 2, which is right here, you're going to collect your data. You're going to graph it. You can see this one doesn't look like a line. It looks almost like it's a different type of curve. So you won't click on linear. It's going to be something else. So replace my data and my graph with something different. You're going to calculate the final velocity and acceleration for all 3 trials. So look at the equations and figure out which ones you're going to use to find the final velocity and the acceleration. You're going to put in a summary table, so that way it's all nice and neat in one place. You can see the averages, and then answer the summary questions. So we're basically doing the same thing twice. We're doing it once with this car on a flat piece of ground for constant speed, battery operated, and then we're doing this one using gravity rolling down a hill for accelerated motion. It's going to speed up. And so we're going to be calculating different things, and we're using Google Sheets to collect the data and to graph the data and give us nice, clean data. And then once again, for the red, get rid of the red and type in your information. All right, and that's going to be our lab for this week. Hope you guys enjoyed. If you have any questions, ask me during class, and it's going to be outside, so make sure you're wearing something weather related. If it's cold or if it's hot, bring something that can handle the outdoors, and I will see you guys soon.